Welcome to the fourth video in this video tutorial series, where you will learn how to run Federated AI Simulations using Flower. In this video, you will get to see how you can send arbitrary metrics from your client apps back to the server app. These metrics can carry information such as what was the training loss, what was the validation accuracy, and any other type of metric you need for your server app to be aware of. For example, you could use these metrics to determine how to proceed with the federated learning process. The code we are going to be presenting here, as well as the code we have been covering so far in the previous videos, is linked in the video description below. And as always, if you have any questions about this video, the best way to reach me and others in the Flower community is by joining our Slack channel, which is linked at the top, or by posting a question in the Discuss forum. So let's jump into the code. So if you recall, up until now, what we have done is we created a new app using the Flower new command. And over the course of the videos so far, we have been modifying it. We haven't done much change in the body of the server function, but we do have added some extra functionality to our strategy by passing a series of callbacks. These callbacks have enabled us to customize how we treat those metrics sent back by the ClientApps evaluate method. Another callback enabled us to adjust the learning rate based on the current round number. And this tiny configuration, which in this case is just a dictionary with one element, is received by the client's fit method here. And then we were able to pass that to our training function. Also, we introduced in the last video another callback, a bit more complex, but still quite manageable, that show you how you can do centralized evaluation of a global model. This function, which you can see here, is executed after each aggregation is completed. This means that once the clients have sent their updated models back to the server, and once the strategy has aggregated those updates and generate a new global model, it gets evaluated on a centralized dataset. Just as we mentioned in the previous video, in some setups there is no central evaluation dataset, so this stage might not be possible, and therefore the only way to evaluate the performance of a global model is by means of a federated evaluation round, which we are doing anyway each time this method in the client app gets executed. Also, in the previous videos, what we did was to replace the dataset of the dataset that we are federating. By default, if you remember, the dataset that was used by default was CIFAR10. We modified to make use of function MNIST. And we went a step further, and instead of partition the dataset in an IID fashion that now we know is not a very realistic way of finding the data out there in the real world, we replaced that partitioner with a more sophisticated Dirichlet partitioner, and we set the alpha value to a relatively small value, which introduced some heterogeneity in the distributions of the datasets available to every client. And we were able to generate some visualizations using Flower datasets built-in visualization tools. And if you remember, for example, if I go to the directory where my code is, we could run this application just by doing flwr run and dot to indicate that this is the application we want to run. So just as a short recap, because we were setting a callback to do global evaluation, our model is evaluated at the very beginning of the federated learning process, and because it is randomly initialized, it is not good at all. It's just trying to do a random guess. But over the course of each round, the model, we can see it gets better and better. First to 0.17, 0.67, almost 78%, and so on. And we were able to get a summary at the end with both centralized and distributed metrics. What we're going to do in this video, that's enough for the recap. What we're going to do in this video is to add a little bit more complexity on the metrics that we return back to the server. What I'm going to be showing is applicable to both the evaluate and the fit method, but since we already have a callback that processes the metrics returned in the evaluate method of the clients, we are going to focus on modifying the metrics that get returned in the fit method of the client. So before we do any change here, we'll come back to this method very soon. Let's write a new callback that will be used to process the metrics returned by the fit method of a client. So for that, I just need to set the argument fit metrics aggregation function. And we are going to create a new function that we are going to call, for example, process fit metrics. You can decide to change the name. Or let's better say handle fit metrics. And we're going to put this function here next to the one that is used for the evaluation. And yes, as you would expect, this is a callback, so the input arguments are predefined and their type as well, and so is the return, the expected return. So we can copy that from this existing callback. What we are going to do now, instead of adding a lot of code in one go, we are going to just loop over the metrics. So I'm going to, and we are going to simply print them. And because we are expecting a result, we need to return something. And because we don't want to do any aggregation for now, we're just going to return an empty dictionary, which is equivalent to the behavior we are seeing now that we are not actually making use of this callback. Okay, so if now we run the code, let me clear this. What you would see is that this callback is going to be called at the end of every fit round, and we will expect to see just the metrics that are already being sent here, the training loss, to be printed. And indeed, this is what we see. Because every client app is returning the training loss in the fit method, we can just see what was the training loss. So far, so good. We are not doing anything special. We are just adding a print statement. What about if my algorithm is more complex, or maybe I want to return other type of information in addition to the training loss? Maybe I have a local validation stage, or maybe I have other settings that I want to use on the server app for whatever reason that is needed for your use case. So let's add a new metric to return. For example, I'm going to communicate a random number. And for that, I'm just going to make use of the random module in Python from random import random. This is nothing super special. Typically, you would do something more interesting than this, but for the sake of this example, this is enough. And if I run the app again, you will see that in addition to the training loss, each client app is going to return also a random element. So these exact same metrics are shown here. You can see there's a training loss as before, and now there is a new random number. Of course, for each client that returned the metrics, the random number is different because of how the random generators work. If we had to use the same seed, this would be all the same. Okay, but this is good, but the purpose of this tutorial is to show you how we can communicate more complex data structures here. Because if you remember, when we were looking into what the metrics data type is, the metrics allow for is a dictionary with keys of type string and then values of type scalar. And if we do look into the scalar, what it is, these are just booleans, floating point values, integers, strings, and bytes. So this this makes it impossible, for example, to communicate back something a bit more complex. For example, imagine I want to communicate back a dictionary. A dictionary like this. Let's say that this is the metric I want to communicate back. My metric. And let's say that for whatever reason, I cannot just have those in the same dictionary. Let's say that makes it inconvenient for my application. Or it could be that I have a far more complex data structure. So how can we communicate this? I can tell you now that if we attempt to run this, this is not going to work. It's not going to work because the metrics data structure doesn't allow for values of type dictionary. This is a Python dictionary, right? It only allows for types as defined here. So what can we do? There are two options here. One option is to serialize the data into bytes. You can do this with the pickle package in Python. Typically, pickle it's not safe to use pickle unless you know and you have control of how that data has been serialized in the first place. You can look into that if those risks don't exist in your use case. You can, of course, use pickle. But for this tutorial, what I'm going to be using is JSON. We're going to serialize into JSONs the Python dictionaries that we have here. So let's see how we can do that. But before, let's add something a bit more complex. For example, my list, and we're going to add 1, 2, 3, and 4. Let's say that we want to be able to communicate this. We need, as I said, to serialize it with a JSON module, JSON package. So we're going to do it like first by importing JSON. Import JSON. And now complex metric as a string, we're going to do JSON dumps complex metric. And if you put the mouse on top of it, you will see that indeed the output we get will be a string. So we know strings are supported in the metric system of Flower, so we can just pass it like this. And now, if you run this, what we will see is that in addition to the training loss, there is a new key called my metric that has this dictionary. But if you look carefully, it is not a dictionary, it is a string. For example, if you see here, you see that this is surrounded by these single quotes, which give us a hint that all this is a string. In other words, I cannot use, for example, these keys to access these values, since the whole thing is a string. How can I revert this from a string back to a dictionary? So before we do that, let's go back to our callback in the server app, and let's only extract this metric, because it's the one that we are interested in, at least in this tutorial. So my metric as a string is going to be my metric. What I'm going to show you now is, for example, this my metric. If I was to print it now, we will see that it looks, because of how the strings are printed in Python, it would look like if it is a dictionary, but in fact it is not. So while it just looks like this, it's going to look a bit like a string, looks like a dictionary that we could actually extract some of its values, but we cannot do that. We need to first revert the conversion to a string that JSON did on the client side. So in order to do that, it's fairly easy. We're going to import JSON here. And now to convert it back to a dictionary, we are going to do my metric equals JSON loads my metric. And that would do the trick. And now to actually prove that all this is working, and indeed this is a Python dictionary, which is in fact identical to the one we have here, we are gonna try to extract the, for example, the B parameter, that random number that is being created. And what we're gonna do is we're gonna append it to a list, for example. And then at the end, we're gonna just return the maximum value, for example. Let's say that that's something we really care about in our application. So let's create an empty list called B values. And then we're going to do B values, append my metric. Then we're going to extract the parameter B. We could have extracted anything else, like this list that we are communicating, or A, but let's do it with B. So once this loop has been completed, we have a list of B values. And the metric we want to report is going to be called max B. And we're going to just report it as the maximum value in that list of random numbers. And just to complete this, handle metrics from fit method in client. And now if we run this, recall I have removed the print statement. What we will see is that in between rounds, nothing will be printed here. But in fact, what's happening is that for every client participating in every round, we are receiving these metrics and we are extracting the B value and only really caring about the maximum of such values. And we are going to print it as well. And we should be able to see it here. And indeed, we see it. This new section in the summary has appeared. You can see metrics, distributed metrics from the fit method, which is different from those in the evaluate method that we had before. If you recall, before we were computing the accuracy with this callback. Now we are just computing the max B with this other callback. And you can see it here, what's the maximum B value in each round. So, of course, this is a very simple handling of metrics. You can do something much more sophisticated that makes more sense to your application. But what I wanted you to learn in this tutorial is how you can indeed communicate as complex data structures as you really want. If JSON for some reason is not sufficient for you, is not versatile enough, you can always serialize it into pure bytes, for example, using Pickle. But just be aware that Pickle has some issues if you cannot really trust where the data comes from. So this is everything for this video tutorial. What we are going to be seeing in the next video is how you can create fully custom strategies using Flower. You will learn how you can customize the way your global model checkpoints are being saved. You will learn how to save all those metrics we see printed at the bottom of once the Flower run command finishes. You will learn how to save them to your favorite format, like for example, a JSON in a particular folder. And you will also learn how you can stream those metrics back to a dashboard, like for example in weight and biases. Remember, you can find all the code presented in these tutorials linked in the video description, and I hope to see you in the next video. Bye.